terms on both sides of the inequality table. You can solve these inequalities like you solved equations with variables on both sides.
Good. And then it says use the property of the inequalities to collect all the variable terms on one side and all the constant terms on the other side. So I stress this with equations, and it's even more important with inequalities. You need to always move your variables first, and then you need to move your whole numbers. Okay, so I want you to write this on your notes. I want you to write variables and then numbers. There's going to be some problems where it doesn't appear to matter which you move first, variable or numbers. But as these problems get more and more complex, I promise you it is easier if you will move the variables first before you move the whole numbers. So what I mean by that, like in example 1 right here, y is less than or equal to 4y plus 18. Before you start moving 18, you need to move both of your y's on one side of the equal sign. Now, it was important with equations, it's even more important now. Always keep your variable positive if possible, because then you don't even have to worry about dividing by a negative, which will have to switch your sign. So in this example, what makes more sense, to move y or to move 4y? Y. Good. So I'm going to subtract y from both sides. What am I left with on the left side? 0. 4y minus y. Excuse me. So 0 is less than or equal to 3y plus 18. Now that I have all the y's on one side, I can move the 18 by doing what? Goodness, thank you. And then what would be the last thing that I need to do? Good, divide by 3. Now tell me my answer in terms of y. Y is what? Good, greater than or equal to -6. We're always going to graph these solutions. You need 3 points on your graph.
Wait, why did you change the sign?
I didn't change the sign, I just changed the order that they were in. The greater than side was still pointing to y here, so I just flipped the order. All right, what kind of circle do I need on y? Solid, pointing which way? Good. Y is greater than or equal to -6. All right, let's look at the next example. 4m minus 3 is less than 2m plus 6. 4m minus 3 is less than 2m plus 6. Do not move numbers first, move variables first. So Riley, what do you think? Should I move 4m or 2m?
2m.
Good. And how am I going to do that?
Subtract it.
Good. Take away 2m from both sides. So I get 2m minus 3 is less than 6. And now I can move whole numbers. So Eric, what would I do?
Add 3.
Good. And last, I can isolate m by doing what? Dividing by 2. Now, I know with equations I told you guys that it didn't make much difference to me whether you left it as an improper fraction or a mixed number. But since you're having to graph these inequalities, it's probably best if you'll put them as mixed numbers so that you can tell where they need to go on the number line. So 9 divided by 2, or 9 halves, is equal to what whole number? Or mixed number? 4.5. Good. Now, to graph those with fractions, remember, just plot whole number points. So I could do 3, 4, and 5. And then just place your fraction in between the whole numbers where it should go. So 4.5 needs to go where?
In the middle of 4 and 5.
Yes. All right. The next part says you may need to simplify one or both sides of an inequality before solving it. Look for like terms to combine and places to use the distributive property. So again, it's very, very important that you simplify first and then you start to solve. I see many, many mistakes of students trying to solve first and then simplify, and it's going to cause you errors. So I want you to write that again. Number 1, simplify. Number 2, solve. So what I mean by that is look at the left and right sides of the inequality sign and always simplify before you start to solve. So for example, here, what can I do to simplify first on the left-hand side? Distribute 2k, 2 times k, and 2 times 3, which would be 2k minus 6. Good. And then what can I do on the right-hand side?
Subtract 3 from 6.
Good. Combine like terms. 6 minus 3.
3.
All right. Now I can start to solve, and what should I do first to solve?
Variable.
Right. And what do you think I should move? 2k or 3k? Good. 2k. So what am I left with on the right-hand side? Good. 3 plus k. Very good. Last step is to take away 3 from both sides, and what's my answer in terms of k? K is what?
Less than.
Good. K is less than negative 9. Remember, on your number lines, I need 3 points and 2 arrows at each edge. You need to make sure you're practicing on your homework, drawing these lines neatly so that they're very legible. So what kind of circle do I need? Oh,
You put the 9.
yeah, I did that wrong, didn't I?
An open circle.
Mm-hmm. Pointing to the...
Left.
Good.
Well,
All right. Why don't you guys try this next one on your own? When you're finished, just put your pencil down so that I know you're ready. Make sure you graph your answer as well. Negative 16 divided by negative 8 is 8.
No, 2.
All right, so it looks like everybody got the correct answer. The correct answer to this question is what?
R is less than or equal to.
R is less than or equal to 2. Very good. All right, let's look at the last part of the notes. If you have a highlighter, you may want to go ahead and take it out. This is very, very important. I want you to highlight a couple of things. It says there are special cases of inequalities called identities and contradictions. Have you heard those words before? Have we heard of identities and contradictions before? With equations? Yes, we have. We talked about these before. Okay, here's the important part. It says, remember, when solving an inequality, if you get a false statement, it's a contradiction, and the answer is no solution. So that's the part that I would highlight. If you get a true statement, it's an identity, and the answer is all real numbers. Some of you on your tests got an identity or a contradiction, but you didn't know what to put for the answer. Okay, so it's really important that you understand when you get a false statement, the answer is not contradiction, the answer is not false, the answer is no solution. That means that there is no possible value of x, or whatever the variable is, that will make that inequality true. Same thing for identity. If you get a true statement, the answer is not true, the answer is not identity, the answer is all real numbers, which tells me any number could be a true value of x. All right. Right, it's either identity, it's either no solution or all real numbers. So let's look at this first example. 2x minus 7 is less than or equal to 5 plus 2x. Okay, so it's simplified, so I can go ahead and start moving variables. So what would I do to move the variables?
Minus 2x.
Okay, minus 2x, good. What happens here is that 2x cancels out from both sides, so I'm only left with negative 7 is less than or equal to 5. Now let's think about this carefully. We need to decide if this is a true or false statement. It says negative 7 is less than or equal to 5. Yes, it's true because it is less than. It does not say less than and equal to. It doesn't have to be both of those things. It just has to be one or the other. So is it less than? Yes. Is it equal to? No, but that's okay. It really can't be less than and equal to. That doesn't make sense. So if it's one or the other, then it's true. And negative 7 is less than 5. So this is a true statement. So my answer is what? Right, all real numbers. What does the answer all real numbers mean about x? What is that saying about the value of x? That's exactly right. You could plug in any number as x, and it would still be a true inequality. Now, we can still actually graph a solution of all real numbers. Can anyone think of what we might be able to do? How could we show on the number line all real numbers? Let's say if we start with 0. Are the numbers greater than 0 a solution of this problem? Yes. Are the solutions less than 0 greater than, or are the solutions less than 0 a solution to this problem? Yes. So you would simply show an arrow that goes both ways from 0, showing that basically any number on the number line is a solution of this problem. All right, last example. 2 times 3y minus 2 minus 4 is greater than 3 times 2y plus 7. So here we have some simplifying we need to do before we try to solve, okay? So what could we do on the left-hand side? Good. So 2 times 3y, 2 times negative 2.
Negative 4.
Okay, on the right-hand side, 3 times 2y, 3 times 7. Still have some more we can do over here. 4 minus 4y.
Negative 8.
Good. Now I have it completely simplified, so I can go ahead and solve it. So what do I need to do first to solve it? Good. Move the variable, so subtract 6y from both sides. And I'm left with negative 8 is greater than or equal to 21.
Oh.
False. Negative 8 is not greater than, nor is it equal to 21. So this is a false statement, and the answer is what? No solution. With an answer of no solution, you don't need to graph it because there's basically no numbers on the number line that will work, so you don't need to graph it.
All real numbers, like when you draw them to both sides, will it always be like that?
The graph?
Yeah.
Yes. Okay,